So let's try this again. Central angle is an angle with a vertex at the center of the circle, and its two sides are radii. Okay? So multiple radius, radii. What would we name this angle right here?
ABC.
ABC. Okay? So we use the three letters around it. This is ABC, so angle ABC. It is a central angle in the circle B to the left. If I were to add up all my central angles, so for example, this angle right here, that's 84. And then what if we looked at this other angle that goes all the way around? If I were to add up those two angles, what should they equal? 360 degrees. Look, y'all are so smart. Okay, 360 degrees. Now, when we have these radii that come out and hit the edge of the circle, it starts to cut our circumference or the edge of the circle into parts. So right here we have a piece of the edge which is between A and C, and this is what we call an arc. Okay, that's an arc, and we would name this arc AC, and we would put like a little arc on top. Shocker, we love symbols in math. Okay, so we have arc AC right there, and we put an arc on top. The arc of the circle is formed by the endpoints of the central angle, and it is equal to the measure of its central angle. So that arc is 84 degrees right there. So arc AC is 84 because the central angle is 84. Those are going to be equal to each other. Now, we have two types of ways of measuring an arc. One is a measure, which is like basically going, what is the width? How wide is this open? And then we also have a length. We're going to talk about length in just a second, but this is measure where it's degree. Then over here, the same way we have a second angle, we also have a second arc. Now, the name of this arc would not just be AC. Because this arc is so much bigger than our little arc or the arc that's like purple over here, we're going to use three letters so we know what direction to go in. And one thing that we have to be really careful about, actually we'll talk about it in just a second. But arcs go around the circle. So I go from A, but before I hit C, what other point do I hit? D. So this again is an arc, but we would call this A, D, C, and I would put like a little arc symbol on top. Since it is so big, and so I have to know what direction to go in. If it just says go A to C, take the short path. But if it has an extra letter thrown in, I have to hit D before I can go to C. So that's why it says ADC. Now, if I want to know what the degree of that arc is, what would I do?
Subtract 84.
So 360 minus 84. And that gets you, I believe, 276. So this arc right here is 76 degrees. Okay, so that's pretty much everything we need to know about central angles. The key is that the vertex is at the center and that your arc is going to match the degree. On Tuesday when we come back, we'll talk about another type of angle, and that's going to be like, what's it called? That's going to have a different relationship. Okay, so now flip on over to the next page. We're going to go right here to arc length. So we talked about how we have arc measure, which you're trying to basically figure out the width. And then we have arc length, where we're actually finding out the length of the circle. So we talked about this the other day. If I go all the way around a circle, what is that called? That's your circumference. But when we're finding arc length, we're finding a piece of the circumference. Okay? There's two pieces of information you need to know for this. I like to use, instead of x, I like to use theta, which we have used theta before. What does theta stand for?
It's X.
A what? Okay, it's a variable, and it's going to be used as a degree. Okay, some sort of angle for trig, for SOHCAHTOA, that type of stuff. For sine, it was like the reference angle. Here, it's the angle of our central angle, or we could say the measure of our arc. So right here, degree measure of arc, we could say or central angle. Right? So that's theta right there. Now, instead of finding the whole circumference, we're only finding a piece of the circumference. So the way this formula works is we're going to do theta divided by 360. Basically, if we're figuring out what percentage of this circle does this arc like cover. This is going to find a percentage. And then we're going to multiply that by my circumference equation, and we're going to use 2 pi r. So we're not finding the whole circumference, we're finding a piece of it. So we do angle degree or arc degree divided by 360 and then multiply that by 2 pi r. And just like yesterday, I'm going to be putting up answers so that you can check as you go while you're working through this. But I'm giving you all of the information that we're going to be talking about today, or that you're going to be practicing today, before I just let y'all go. So we go on arc length. Any questions on that?
No, ma'am.
Okay. Arc length, it's just a formula. Don't overthink this. Some people are overthinking it and they come up and they're like, Miss Flores, how do you do all this? And I'm like, just plug it into the equation. And they're like, oh, okay. So don't try to make that harder than it needs to be. Okay, now we're going to go to the next page where it says congruent chords and arcs. I'm going to say this over and over and over again. And I think today is a great example of this. What we are doing with circles, each individual thing, not super difficult. But there's a lot of information. Like today, we are going over a lot of information. But each one of them, not very difficult information. This right here specifically, very, very straightforward, very, very easy. So the first thing we're going to look at is my chords. So I have chord AB right here. What is the other chord that's here? CD or DC. Those are two chords, right? Then we have arcs that are made from those chords. Now these are little arcs, so I only need 2 letters. So what is the arc that's made with chord AB?
BD?
Mm-mm.
Wait, what?
That's you.
Oh, AB?
AB again. So AB, that arc is made from the chord AB. So what arc is made from the chord CD?
DC.
DC or CD. It can go in either order. So right here we have an arc and we have chords named by the same thing. So when we go over here, it says 2 chords are congruent if and only if. Okay. If and only if their arcs are congruent. So what that means, and if you notice there's a double arrow right there. Do we see how there's an arrow going both directions? Mm-hmm. So when we talked about if-then statements, we said if this, then this. That goes one direction. This goes both directions, meaning that what we're about to say is if the chords are congruent, the arcs are congruent. If the arcs are congruent, then the chords are congruent. Both are going to be true. So right here, if I said chord AB, I'm going to put a line on top because this is a length. When we're talking about chords, we're talking about the length of that line. If that length is congruent to the length of CD, then the measure of arc AB, which is my purple highlighted part, is congruent to the measure of the arc CD. So if your chord lengths are the same, then the degree measures of your arcs are the same. Again, not a difficult concept. We just got a lot of information. The last thing we need to look at, this one is not difficult, but it is a little bit more involved. So if I was looking at the distance between AB, right? We have chord AB right here. What line represents the distance between AB and the center right here, E? FE. That is your distance between the chord and your center, correct? So what we're going to, what this next part is going to say is, if and only if they are equidistant from the center. So for example, that FE right there, that distance, if that distance is the same as the distance of FG, you see those two blue lines right there? If those are the same length, then your chords are also congruent. So that's what we would put right here. We would say if FE, that distance, is congruent to GE, that distance, then chord AB is congruent to chord CD.
Wait, how are we sure their arcs are congruent again? Is it 'cause of
If the chords are congruent. So if you
How are we
have,
sure the chords are congruent?
you're going to have one of the measurements. You're either going to have arc measurements or you're going to have chord measurements. So if you have arc measurements that are the same, then we're not assuming, we know that the chords are also the same, and vice versa. If they're trying to figure out the chord or the arcs, but they give you that the chords are congruent, and you can kind of see that right here. So like right here, what do they tell you in that picture?
That ST and S whatever.
Right. They don't tell you the actual length of the lines, right? They tell you, though, that they're congruent.
So you just set those people to each other and solve for like.
Exactly. So we're going to know that these arcs are congruent, and we can set them equal to each other because we know that the chords are congruent.
Wait, but aren't both of them just 115 anyways? Or is that the angle?
They're both arcs are 115, but it says find x. So they're going to use that to find x. Okay. So that's going to be kind of what they give you. Okay, so now let's go to the second part. It says if the diameter or the radius is blank. So let's look at right here. This HE, that right there, what is that?
Diameter or no radius?
That's a radius. And what is the relationship to that and BA? They're perpendicular. How do we know they're perpendicular? Because we got a 90-degree angle. So right here, if a diameter or a radius is perpendicular to a chord, then it bisects. What does bisect mean? Halves, cuts in half. It bisects the chord and its arc. Okay. So the example of this, the radius I was just talking about is HE right there. So if the radius HE is perpendicular, that upside down T, to AB. So if those two lines are perpendicular, correct? Then we know that AF, this line right here, is equal to what? BF. Those two halves are going to be equal. So AF is congruent to BF. And the arc AH is congruent to what? The arc BH. Again, most of this super straightforward. They're cut in half. All the stuff is equal. Like, that's what we're pretty much looking at on here. Does anybody have questions? Okay. Does anybody need more time to write this down? Because we got one more thing. If you need more time, that's cool. Okay, if you are done writing this down, what I need you to do is go to the very front page of your vocabulary. There's 3 vocabulary words I want us to touch on that aren't in these notes, but we do need to talk about. So go on the vocabulary page, that's the very front page of your notes, and then go to the back of it. Anybody still need this? Okay, we're going to go, it's going to be on this page right here. And we're going to be looking at minor, major arc, major arc, and semicircle. A minor arc. When we think minor, we need to think small. It is a small arc, which means it's less than 180 degrees. When we name a minor arc, it's usually named with only 2 letters. Like I said, it's short and sweet. If you have A, you go straight to B. Go the shorter route. Then we have a major arc. A major arc is the big arc. So when we think major, we need to think big. That's going to go over around the majority of the circle. And again, arcs go around the circumference. They're going around it. I'm going to give you all an example of this in just a second because some people are asking questions last period, and I think that I want to make sure I cleared that up with y'all before y'all get started. And then we have a semicircle, which is half a circle. So that means it's exactly 180 degrees, and this is always going to be made by a diameter. So a semicircle is made by a diameter. This can be used with 2 or 3 letters. It just kind of depends. You just need to look to see if it's a diameter that's cutting it in half. Okay, anybody still writing this down? Okay, if you're good, you're going to go to this page in just 1 second to work, because we're going to do what we did yesterday, where y'all are going to just kind of work through all these practice problems. I would do a couple at a time. I would do a couple of the central angle stuff, check your work. Once you feel like you got the hang of it, then I would go to the arc length stuff, work through some of those problems. Once you feel like you got the hang of that, check your work. And then do some of the chord arc problems. And I'll throw some stuff up on the board as we go. But before we go and do anything, I want y'all to look up here. You don't have to start working on number 2, but I want you to look up here and kind of see what you need to be careful about. So on number 2, what type of lines are going through this? Diameters, right? So even though I have one angle, I know that JL is a diameter. So what does a diameter do? We just wrote it down. It cuts it in half. So that means from J all the way to L, what is that right there?
180 degrees.
That's 180 degrees right there. So we should know that, okay? The second thing we need to look at is right here where we have 21. This angle is 21. What is this angle right here?
21.
Why?
Because they're vertical.
Because they're perpendicular.
Not perpendicular. They're vertical. So right there, those are vertical angles, so they're congruent. Okay? The last thing we need to talk about is right here where it says JKM. What people love to do, please have your eyes up on the board. This is what people love to do. They go JKM. But if you notice, JKM is a what? What is the sign on top? Tell me. It's an arc. It is not an angle. Arcs never go through the circle. Arcs go around the circle. So I'm going to start with J. I'm going to go to K, and then I go around to M. I'm going to say this, and people are still going to do it. With an arc, never go through the circle. Okay? Arcs have nothing to do with those lines. You go around it. It's angles that you go through. So for example, right here where I have JNM, I'm going to start with J, I'm going to go to N, and then I'm going to go to M. That is an angle right there. So angles go through and use your lines. Arcs go around your circle. Okay? Does that make sense? Okay, so those are the last two things. So the rest of the class period is going to be for you to work on stuff. If you have questions, please ask me. Like I said, I'm going to put these answers right here on the board. So like I would go through questions 1, 2, and 3. Try it on your own. I don't have the work shown. I just have the answers. Check your answers. If you did it right, awesome. If you didn't, ask a friend that's sitting next to you or have me come over and ask me how to do it. Once we check a couple of these, then I'll move it to the next part and all that kind of stuff. So we got about 45 minutes to do all of this.